Well, hello everyone, and welcome to another edition of Geometry Concepts and Skills. Today we're starting a new chapter. This is chapter 6, and today we're going to be looking at polygons. Now, what are polygons? Well, just like it says right here, I am glad you asked. Polygon is a closed figure made up of straight lines that intersect only at their endpoints. Ladies and gentlemen, I'd probably say that polygons that you're looking at right now are probably the most common attribute of what we all think about when we think of geometry. It's kind of like the main shapes that you look at and you think of every day when you're thinking about geometry. Now, the thing is, we do have some rules, and it had to kind of do with the particular definition that I just read to you. First off, it is a closed figure. It cannot be open in any shape, weight, and form. It also can only be made up of straight lines, no curves whatsoever. And last but not least, it intersects only at the endpoints. So your main basic examples is like what we looked at last chapter, triangle. Triangles are a polygon. They're a closed figure. As you can see, there is no openings whatsoever between those points. It's made up of only straight lines. This guy got no curves. And last but not least, it intersects only at the endpoints. So let's kind of take that a little bit further, and let's take a look at what maybe some examples are. Well, let's look at some non-examples. Let's put it that way. Here are then our non-examples. As you can see, we got no straight lines. So anything circular at all, anything that's got curves ain't good for this. We do not want curves when it comes to polygons. Secondly, something that looks as ugly as this. That is not a closed figure. Not closed. It has to be sealed. There cannot be any, let's say, air coming in between. It has to be completely shut off. Meaning if I were to draw a straight line from that point to there, that'd be good. But the fact that this doesn't have that means that this is not a polygon. And then last but not least, this hourglass bow tie looking shape here, we cannot have any intersections like that. That's bad news bears right there. So, in essence, good. This, bad. All of this, bad. We do not like that whatsoever. All right, so that's just kind of the basics right there. But I want to now take a look at more of the anatomy of what a polygon is, all the different parts to it. Now, some of these you should already be familiar with. The idea of sides. So let's say I'm looking at this particular figure right here. This is also known as a pentagon or a five-sided polygon. These sides should be basically a review for you. Here's side AB here, as you can see. We got BC, CD, DE, and EA. All of those being sides. Vertices you know as well too. Those are basically your points, your corners, the angles, so on and so forth. Like here, B, A, E, D, and C. Those are all ideas or examples of a vertices. And then last but not least, diagonals. This is a little bit new to us, but I'm sure that most of you guys can be able to figure this out. It is segments that connect a vertex to another non-consecutive vertex. So like the diagonals from, let's say, this E here would be B and would be C. Our diagonals from C would be something like A and would be something like E as well, and so on and so forth. Next, naming a polygon. Here's the easiest way that I can describe it for you, ladies and gentlemen. Choose one vertex, and then just go around in a circle. So here, like you see in the bottom, you got something like A, B, C, D, E, and the respective. I started at A, I pick one point, and I go around a circle. It doesn't matter which way you go. If you want to go clockwise because you think that's cool, well, then go right ahead. If you want to go counterclockwise because you think you're some kind of rebel, well, then do it. It doesn't really matter. But really just pick one point and then just go around a circle. So like A, B, C, D, E, that would be an example. Or again, you can go the other way. Let's say you started here at C. You go B, A, E, and D from C. Doesn't matter. Just start with one and go around in a lovely, beautiful circle. Now, after this, we're going to look at something called convex and concave. These are the two different types of polygons that we are going to be seeing throughout the rest of the year. A convex, it's where all the angles are pointing out. Everything is shooting outwards. Out, 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 out. I bet you can guess what I'm going to say for this last one. Out. It's moving all away from the center. That's what you got when you have convex. Concave. The easiest way that I can describe it is it's like one of the angles caving in. Hence the word cave. It's like a cave. If I got myself a cave, it goes inward. See? We could even build a little fire in our cave. Here's me being cool in the cave. The bottom line is if you see any kind of cave portion of a polygon, it's going to tell you that that particular polygon itself is concave. It could be a large cave. It could be a small cave. You could have something as simple as everything looking like it is convex, and then you get this magical little cave there, and then everything else is convex. That portion means it's still concave. If it's got a cave part to it, it's concave, ladies and gentlemen. All right, almost there. Almost done. Next thing we have is we have naming polygons. You want to keep this handy. You want these notes to be around you. That or you got to memorize, which you see right there. But those are all the different ways that you are going to be naming polygons. And each one of those names has a representation to the number it's associated. The word tri, meaning 3. What is that? A 3-sided figure. Quadrilateral, that's a 4-sided. Pentagon, hexagon, heptagon, octagon, nonagon. All of those have to do with the number in which they're associated with. Now, you also are going to see here a couple of these sides are starred, like 7, 9, 10, and 12. Those are just ones that seemingly, I believe personally, that a lot of people miss, especially the heptagon. That is probably one of the most missed particular named polygons that we have. You probably want to make sure that you know it. Definitely, you want to try to maybe have at least memorized up through 8, in my personal opinion. Anything other past 12, you just take the number. So let's say like here you have 22. We'll just call it 22 gon. But don't worry, that's not like you're not really going to be seeing that. So don't worry too much about that guy right there. Now, last thing that I want to cover is the almighty quadrilateral. We're going to look at the quadrilateral quite a lot this chapter. The quadrilateral, well, quad, it means 4. Lateral is in reference to a side, hence why we have the name a quadrilateral or a 4-sided polygon. Now, here's a big thing. You just came back from a couple chapters looking at triangles specifically. What is one of the main things that we learned about triangles in the last couple chapters? That if you were to add all of the angles up in a triangle, so here's a triangle. If I was to add up, that's a bad triangle, but if I was to add up this angle, and that angle right there in that crummy looking triangle, they would add up to 180 degrees. Well, I'm here to tell you something, ladies and gentlemen. A quadrilateral, if you were to add up all of the angles, it adds up to 360 degrees. Why might that be, maybe you ask? Well, if I take a look at a just normal 4-sided figure, if I were to draw a diagonal from one corner to the next, like so, what is it you see in each one of these? Which one do you see in each one of these halves of that diagonal line? You're going to see 2 triangles. 180 degrees here, 180 degrees here, and if I were to add up 180 and 180, it equals up to 360 degrees. Little did you know, and we'll cover this more later, is that if I would make a 5-sided figure, I would just add on another 180 degrees to that 360 or 540. So for every side that you add on to a polygon, its angle measurements are going to add up to an additional 180 degrees. So for 5-sided, it'd be like I said, it'd be 540 degrees. If I were to then have a 6-sided figure, it would be 720. Again, just adding on 180 every time. Now, again, with quadrilaterals, this is extremely important. If you were to add up all the angles, equals to 360, 360. Look at all those exclamation points and those stars, ladies and gentlemen. That means this is extremely important and something you don't want to forget. Now, this is a lot like solving for a triangle. So I'm going to take a look at number 1. I'm going to have you do numbers 2 and 3 for then the next time that we meet. But for number 1, it's just like what you did with triangles. You are simply going to add each and every one of those angles, and then instead of setting it to 180 degrees, we're going to set it to what? That's right, kids, 360. If I see any 180s, I'm going to be very, very upset. So without further ado, let's rock. I'm going to start with my variable first. I've got x. Then I'm just going to go around in a circle. I'm going to make it easy. If you start just going x to 57 to 76, you're going to get confused, especially when we start tacking on to more sides in later chapters. So I'm going to start with 1 in my variable, and I'm going to kind of work my way around. So x plus 108 plus 57 plus 76. And when I add all of those together, it's going to equal 360 degrees. Now, we have to add up all of those wonderful like terms that you see there. So I got to add 108, 57, and 76. And when we do that, we're going to get 241. So now x plus 241 equals 360. Again, 360, 360, 360. If I see, again, anyone putting 180 there or there, heads are going to roll. Well, not really, but I'll just be pretty upset. Now, what do we do from here? You all should know. Subtract just 241 from 360. So then when we do that, we'll get the remarkable number of x equaling 119 degrees. There you have it, ladies and gentlemen. Again, I want you to come back the next time we meet, and I want to see numbers 2, and I want to see numbers 3 done. Again, numbers 2 and 3 are on your own. And what are we not going to see? No 180s. More 360s. Remember, quadrilaterals add up to 360. All right, ladies and gentlemen, make sure you get those done. We'll be seeing you shortly. Have a good rest of the day. We'll see you soon. Bye-bye.